So now we can look at the definition for the current. An electric current can be described as the flow of charged particles such as electrons or ions moving through electrical conductor or the space. So from this definition, we all know that nowadays we normally connect electrical circuit through a wire or known as the traces. So for example, if you have a wire, this is a wire, for example, a copper wire. Why? Because a copper wire is a good electrical conductivity of current. So why is copper so important? So we all know that everything made up of atoms. That means a copper is also made up of the atoms. So they have a nucleus and what is known as the cell. So this can be the nucleus. So a nucleus of the atom, it consists of a protons and neutrons. So protons is a positive charge particles and neutrons has a zero charge. So in that case we have protons. And how about the cells? The cells have what is known as the electron. So because we know that the positive and the negative, they have a force of what? They have a force of attraction. So every time with the nucleus, it will attract the electrons to bound with the nucleus. So in that case, it provides stability. So for the copper, we have only one electrons which is loosely bound by the outermost cell or the valence cell of the atoms. So that means it is unstable. That means you don't need bigger force to push these electrons out of the outermost cell in order to make this atom become stable. So this is very important why they choose copper, because it has only one electron in the outermost cell. So the case in which if we apply a voltage source across this copper conductor, if we apply a positive voltage source, that means this force, like we said earlier, it is capable of applying a force that will push these electrons to go to bound with the other atoms of the copper. So this is very important. So in that case, with the exchange of, for example, electrons and the holes of the copper, it provides the movement of the current. So the current, we normally say in an electrical circuit, for example, if you have positive and the negative, and you have, for example, a resistor and the ground. So this force will normally produce the flow of the current. So the movement of current, there are two sets of movement of current. The one which is from positive to negative, we normally call it conventional current. So if you look at the conventional current, that means you can say it is the movement of the holes. Movement of the holes. So because if this will have many holes, which is unstable, because it needs electrons to fill it in order to make it stable. If you study something like a chemistry, you will look at the bonding between those electrons. So in that case, conventional current, that means the movement of the holes. That means the direction is always from what? Is always from the positive to the negative terminal of the battery. So this represents the flow of conventional current. So the other one, which is described in terms of the electrons flow. So for the electrons flow, you have direction which is like this. So that means this is the movement of electrons. So in this one, we call it the electrons flow, apart from the counterpart, which is the conventional flow of current. Now we have the electron flow of the current. So we can say it is the movement of electrons, and it is from negative to positive. So this is the difference between the conventional flow and the electron flow, which describe what is a current. So that means in a current carrying conductor, that means the voltage does not have any kind of charge. Voltage is nothing but only a force. Those electrons which are present in the conductor, because many atoms, when they bond together, they have a lot of electrons which are floating free from each of these atoms. So if you apply the force to one end of the conductor, and the other loop which is connected to the negative terminal of this supply or the voltage source, then there is this movement. So in that case, we all know that from the voltage, which is the power source, which pushes what the electrical charge or the charged electrons through a conducting loop. So in order to complete the loop, it must be connected to a positive and a negative to allow the current to flow through the electrical circuit. So this is very important. So there is also formula which describe the flow of current within a second, but in this video series we are trying to explain the difference between the voltage and what is a current, the type of flow as in conventional and electron flow, and at least you can see from the atom of this particular conductor. And also you can see there are other metals which also a good conductor, but in that case we can see that they have some electrons or more electrons on the outermost shell, which makes it a little bit harder for the current to pass through, because in order to make it stable. But for the copper, it has only one electron. So pushing this electron outside of the outermost shell, it's very easy. Unlike the others, they have more than one electron, so they need more electron volts to push. So if you look at the electron gap, which is a diagram that represents the force that is required to push the electrons out of the outermost shell, because there is another force in the nucleus that want to attract the electrons to the nucleus. But since this in a copper, this electron is loosely bound to the nucleus, you only need a smaller force to push it out to bond with another atom. So this makes copper become a good conductor of electricity.